morning, everybody. Good morning. How were the beers yesterday? Too good? I hope not too good. I hope you're at least as awake as I am, because I'm also not much of a morning person. But we still got an interesting topic. OpenTelemetry. Who is already using OpenTelemetry, just to get an overview? That's not a lot. Okay, we'll try to change that. So we'll spend the next 50 minutes on seeing why and how you could change that. But before diving into OpenTelemetry itself, observability is this term that everybody is throwing around, and then that will magically make everything better. Probably you have seen this image, and then some people will tell you that this is observability, and others say like this is not observability, and then you can have a big argument around it. I think there is still a lot of value to it, even though this does not equate observability in my opinion. It's more like you have three types of things that you commonly want to collect from your applications. Logs, metrics, and traces. And that you have like these intersections, or how you can combine things to get more out of that. So for example, you can have your logs, and then you have tracing, which is normally request scoped. So every log message within that one request might get a unique ID. And then you could, for example, correlate all the logs from a specific event or request together. So there is overlap between them, and you can get more value by combining them. And that's kind of like the idea of what observability is doing. But I don't want to spend too much time on observability itself. It's more like you have different types of data that you want to collect to get more value out of your systems. Though, why some people say that this is not observability, it's a bit like saying this is like gasoline, motor oil, and tires is like the essence of Formula One. And it's kind of the same thing for observability, that logs, metrics, and traces are the foundation of observability. But just like for Formula One, like the things that are the foundation are not the essence of why we want to use them or why this is exciting. So I'll take you a bit on a journey of why these things help us and what they make better and why we want to have them. By the way, observability is an attribute of your system that you cannot buy, though the sponsors downstairs can totally sell it to you. So if you talk to some of the sponsors, they will have an observability solution that you can buy, though I don't think that you can actually do that. It's more about the attribute of a system to have like insights into a system to figure out what might be a problem or what might be broken. So those coming from the classic world of like monitoring, and this is the last piece about observability in general, is like monitoring that what you have on a dashboard and what you can watch all day long if something changes color or goes up or down. Monitoring was very much about like a bank statement telling you you're out of money on your account. Whereas observability is much more about the why are you out of money. It's telling you that you spent all your money on computer gear, chocolate, or maybe beer and Belgian chocolate yesterday. So observability is much more about the why, and not just like that is the state you're in, but it tries to give you a much deeper introspection of why are you in this place and what is the reason for something being slow or something giving you an error or whatever. How did we get here in the first place? A long time ago, this was how many of us built our applications, or maybe we are still doing that. So you had my monolith, and then it was running maybe in that cloud, but it was running somewhere, and it had a load balancer maybe, but it only had a single database, and it was a monolith, and you were running that, which was a nice and simple world, right? But if you're doing conference-driven development, that's not what you're doing nowadays. What you're doing nowadays will look like something like this probably, where you have lots of little services and lots of databases, and everything talks to everything. And it's very hard to figure out why something is slow or broken. And it's not as easy as it used to be just to tail a log file, because there's not one log file telling you what is happening anymore. You suddenly need to have like 10 different log files open, and you need to correlate like what's happening in this service, what is happening in that service, and how does it all play together. Also, the information why something slow is suddenly much, much harder, because it could only be one single service in that mix, in that wild kind of like everything calling everything ball of mud, that is slowing down your service or that is throwing errors. So you need much better tooling to figure that out. And it is in that area, or in that regard, a much better time for vendors to play, because you really need the tooling, since you cannot simply watch the CPU on a host or tail one log file anymore. If you have a distributed architecture like that, that's simply not a thing. And why am I talking about that? I'm working for one of these vendors. So I'm working for Elastic, since I always keep my introduction for a bit later of why am I even doing this talk. We have the classic elk stack and extended from there quite a bit. So we are also very much in that observability space. And I want to show you a bit of like how we see things and how we see things moving, and why OpenTelemetry as a general standard in that area makes so much sense. So observability of what many are doing is, you remember when your parents were telling you, oh, we don't need to buy something, we still have that at home, and then it was often like a crappy version of that. And that's oftentimes when you say like, oh, we have observability at home, and then your observability is like a system out println, which is definitely not observability. But how can you do this right? Or what are the components that most of us are using? So I assume that pretty much everybody is using logs in some capacity, right? And then that's what we do, but there are many other log solutions, and could look something like this. You have like some data, and then you have a timestamp, and then you have a log message, and then you could, for example, figure out all the things that failed or whatever you're looking for. By the way, to make your logs much more useful, and that's a bit independent of OpenTelemetry, but OpenTelemetry is very strongly playing into that, is to turn logs to events and have much more metadata around that. What do I mean when I say metadata? Here I have an example where, for example, I have a login service. So I'm using Spring Security, and Philipp failed to log in with password, whatever. So that's the classic log message that we've all been using, and that's fine. Let's say that's fine for human consumption, but it's not helping you much for figuring out what is going on in your system. What you want to have is like, you want to have these like, these things down here. So for example, I have an event category that says, this was a login failure, and the user that was failing to log in was Philipp, and that was the IP address where this came from, and this was the endpoint where this happened. Because all of this you can then graph out to figure out what is the ratio of login failures and login successes. Is somebody trying to brute force my logins? Is it just one user trying to log in and failing, or is it many users? So you can have all of that information up here, but that's only human readable. And you probably don't have enough people on your team to read the thousands of log messages you get every day. That's why you want to have a more structured information to actually figure out what is going on. And observability, but OpenTelemetry as well, is playing into that you want to have much more of these event-like things where you don't have just a log message, but you have much more metadata around things. And that is one of the things that makes a big difference between a classic human-readable log line, and something where you can figure out what is that ratio, what is going wrong, what do I need to look at, or how bad is something. So having a more structured approach to that gives you much more options. Otherwise, you probably cannot hire enough interns to stare at all the dashboards and log lines that you're producing every day. So metrics are probably used by almost everybody as well, probably in the form of Prometheus. Maybe. Who's using Prometheus? Okay, that's a lot more than OpenTelemetry, so let's see. And then you spit out some whatever dashboard, and could look something like this, or whatever your dashboards look like. And then there is tracing. Who's using tracing? Okay, that's more than OpenTelemetry. So who is using something other than OpenTelemetry for tracing today? Okay, that seems to be the majority. Cool, which is fine. Let's see, or you're probably using something, one of these. Zipkin or Jaeger are very widely used for tracing. And yeah, Jaeger doesn't always look that mad with the pink eyes, it's just the background color. But those are widely used for tracing. And then our take would look something like this, but let's skip over that and see why tracing and application performance monitoring. Both of these terms are kind of common. Some people make a strong distinction that APM is kind of like what you used on a monolith, and tracing is what you use in a distributed system. I don't really make that distinction that strongly. For me, it's like you want to have, or you want to follow a request as it is working throughout your system, and you want to see what's happening in that. And that the means just change over time. So that it's like you have a request and you look at that request. And just in general, conceptually, how the three things I've been talking about fit together. Metrics are great because they're at one point in time, they give you a numeric value, and you can easily aggregate them, and you get a very nice overview of what is the latency, what is the error rate. Metrics are very good at giving you an overview where you are, but they don't really tell you why you are there. Like, they can tell you that your error rate is 10%, but they don't really tell you why you have a 10% error rate. Logs are very good at this point in the code, something specific is happening. But it's very line-based, and it's also not very much like the full request, but it's really just at this point in the code, which has its value, but it doesn't tell you so much from the user's perspective. That's where tracing is coming in, because tracing is kind of like switching the scope, and the scope is one user request. That's what you try to figure out in a trace. So you take more of the user's perspective to see how fast or slow is something, or is it successful or not successful, and where is that happening. So all of those three have their place, but only if you combine them properly, they will tell you the full picture. So that the goal of tracing in general is that you have a transaction flow. Like, if you have like a distributed system, every system is generating some piece of information that has a unique ID, and in the end, you try to reconstruct that one single request to see where did it start, where did it end, where did it spend its time, where did it error out, or did it return successfully. That's what you want to get. How you generally do that is the request hits the first service, or wherever it comes into your system. You give it a unique ID. You keep that unique ID as the request is kind of like working its way through your system. And then you can reconstruct all of the little steps in there through that unique ID as long as you keep that. Normally, it's an HTTP header. If you're using a queue, you need to use an attribute in the queue. You always need to propagate that unique ID to keep track of what's going on. And then you can afterwards reconstruct them and visualize what's going on. To do that, you generally have agents, which are language and framework specific. So for Java, there are Java agents for tracing, and they know what is a request, when did it start, when did it end, and they can capture all the metadata around that. And basically the power of an agent comes from understanding the language itself, but also third-party things. So for example, pretty much all the agents out there in Java understand what is JDBC, and they can extract the SQL query that you're submitting through that JDBC request. And then if you're using Hibernate, it would understand what is Hibernate. If you're using, for example, Redis, it would understand what is a Redis request and what was the actual Redis request and how long did it take. But all of those are very application specific, and that's kind of like the power of where agents come in. They need to understand all of these different frameworks and databases to give you the maximum overview of what you can do. And agents generally try to perform with very little overhead since you have them continuously running. They are not like profiling. Like JVM profiling, where you connect to the JVM to profile, is normally something that has quite some overhead and that you don't constantly run, but only you do that when you're looking for a specific problem. Agents you run continuously to have that overview of how is that system behaving all the time. And Java is kind of special in that regard, because you can add Java agents to an application at runtime through the Java agent concept, which is like, normally we start an application with the main, but in Java we have that pre-main and agent main where you can hook into your application to instrument it at runtime. I think with the exception of .NET Core, this is not possible in any of the other languages. There you would always need to have that as a build dependency, and you would need to manually instrument it at least manually start it. Whereas in Java, with the Java agent concept, you can just add an agent at runtime, and you don't need to think about that before. Just a quick look at how that works. This is a very, very simple application that just prints hello and then whatever argument you give it. This is the manifest file, and then how you could call that is you run that jar with Java agent, and it would give you hello and then world for your simple program that you're running. So basically you can instrument that rather than starting with main, you can hook into pre-main to instrument the application. And where this is really useful is, for example, if you want to say like which classes were loaded in my system. So for example, this would be the instrumentation in a pre-main method, where I add one of these transformers where I can extract which classes were actually loaded. So things like that give you a lot of overview of what is actually happening in your application. The same thing with ByteBuddy, which is probably the most widely used library to instrument through Java agents. Pretty much all the agents out there use it because it abstracts so much pain points of the internals away. That's the same thing here. It's again saying these are the classes that were loaded, and it's just extracting with a slightly more or nicer, a bit more longer at first, but a nicer syntax to extract all of the classes that were touched so far. Same thing if you want to know how long did a specific method take. For example, you could have a method on enter and on exit, and they basically take the milliseconds on the start and the milliseconds at the end, give you the difference, and then tell you the execution of this block of code took this long. And these are exactly the things that any agent will do. So they know how much time did you spend in which part of the code, what code was even loaded, they will catch errors, and so on. So that is really what the Java agents do and give you. This is the same thing then for collecting the time through ByteBuddy, but let's skip over the syntax because it's not so important. And then you have distributed tracing, as I was saying, with the unique ID. You generate the ID, and then you keep it as it works throughout the system. And what you have is you have the trace, which is the entire request, and that's a directed acyclic graph, the DAG, which is basically request comes in, and then it fans out to all the services, and at the end, it probably gives you back a response. And this is the graph that is kind of like spanning throughout your systems as the request works. And then you have every method basically is a span. It's a named and timed single operation that could also be nested. And then you have a span context, that's the ID of that request, and the context propagation is keeping that ID, which is normally like a header or in a queue, an attribute. So that is how tracing works. You have generally the agent to instrument, and then you have, in a distributed system especially, you have those unique IDs that propagate with it. So every single system would extract with an agent the relevant information, send it to a central place. That central place can then store it and reconstruct the flow of your application. The problem here is that different vendors at different points in time started with different trace IDs. So if you have UberTrace ID, which system is using UberTrace ID? Yeah, shout. It's Jaeger. They started as a header UberTrace ID. For example, we also started our own APM, and our IDs look totally different. So the problem here is you cannot mix and match these. Like if you start with one system, this cannot work with any other instrumentation of another vendor. And to solve that problem, OpenTracing, or OT sometimes, abbreviated, started, which is like a vendor-neutral API for tracing, which basically defined like how do the headers look like. And I like this one here especially because it also shows you have a service A and a service B, and you can see this is the entire request. And then you have the parent span here, and it spins off multiple child spans, which could be like method calls here, and it then spins off into another service. And it also shows how logs play into that. So all of this is the request, and then you have, at specific points in the code, you have a log, but it's very much like piecemeal, or it's like at this point. If you give every single log event like the unique ID of that request, you can actually recreate or collect all the logs together afterwards, which can give you a much better picture of what is happening in a request from your logs perspective too. And this is how it defines these headers. So you have a trace ID and then a span ID, and then you can give baggage items, which is like key value pairs that you can attach to that. And that is what you propagate. The problem is that open tracing is only headers. There is no wire protocol, so it doesn't specify how two different services would talk to each other over the wire. It doesn't support, or it doesn't cover in or out band. So in band is like how to propagate over the network between services. Outband is how to send it out of the application into the backend where you store those. To kind of solve that problem, W3C trace context was started, which basically says how to propagate that information across systems over the wire. And that is what OpenTelemetry then is also building upon. That's what those headers look like and how they are propagated. But what OpenTelemetry is bringing is, so Open Tracing, OT abbreviated, was just like, these are the headers. W3 trace context is like how to propagate them, and OpenTelemetry is then adding the implementation of the agents on top of all of these. So it is not just a wire protocol, how to propagate that and how the systems interact, but it also adds like how the instrumentation can actually look like. It's an open source project, CNCF incubating, and it tries also to combine not just traces, but also metrics and logs, and the maturity is also in that order that traces are the most mature, metrics are also usable, and logs are very early on. And it supersedes or replaces Open Tracing and Open Tensors. And Open Sensors, which was a Google implementation, but that's less widely used. Because OT was taken by Open Tracing, OpenTelemetry is normally abbreviated with OTel, because OT was already taken. And OT is not off topic in that regard. So what you want to have is, you want to have, for your observability solution, you want to have one way to instrument all your code to do that, and you want to have that in a vendor-neutral way. So OpenTelemetry is a collaboration of multiple vendors from Google, Splunk, Honeycomb, Elastic, New Relic, and many more are in there. So basically what is standardized, like how do the agents communicate, and even the agent implementation, where the different vendors compete is on the back end. So basically you send the information out, and then when you collect it, reconstruct the requests, show what is possible, or have like anomaly detection on top, show what is slow, etc. All of that is then vendor specific, but the information collection, that is vendor neutral and is just a generic implementation that everybody can use. For the status of where the different projects are, tracing is stable, and that's, I think, pretty much the train where everybody is heading nowadays, more or less, with their tracing. Metrics are stable, whereas the SDKs are, some are stable, and some of the SDKs, like Java is stable, but the others are not yet, or not all of them are stable, so it's a bit mixed. And logs is still in the draft phase, so that is not something that you would want to use today. But it is changing quite quickly, so you could, or check the status page in 6 months or so, because it might be a very different picture. And you can integrate 3 ways into OpenTelemetry, which is, I think, one of the things that is not so well understood, or something that is also the power of it. So what you have is the gray thing here, that is OpenTelemetry, that is like the open standard that is not vendor specific, and that, I don't know, lilac or whatever color this is, thing here, that is vendor specific. So for example, here, in all the various programming languages, I can have my OpenTelemetry agent that could have a vendor specific exporter that then talks to whatever vendor system you're talking here. That could be, I don't know, Splunk, New Relic, Elastic, whatever you want, you could have here. What is the downside of this approach, or why is this not so popular? Because here, for every single language, you need to have your custom exporter. So you need to have somebody who writes that in JavaScript, in Java, in Go, in Python, in .NET. And for C, you even need to write, for PHP, you need to write C, because that's the extension that you need to have here, which is very tightly coupled to the vendor, and you need to have that exporter for every language. That's why it's kind of a bit painful to do. One other thing that OpenTelemetry has, it has a so-called OpenTelemetry collector. That's like a proxy that can collect, for example, on what an availability zone, collect all the information from there and then forward it in a central place. So what you could have is, there is the OpenTelemetry protocol, and we'll get to that in a moment. You could, here, this is all kind of like gray, so this is vendor agnostic. And then only in the OpenTelemetry collector, you have that single point of exporter that is in one single place configures and needs the custom code to actually export to the vendor. This is easy to integrate. This is what we started at first, but I think it's also not as native as you would want to have it. The other thing that you can do, and for example, we are doing that and we believe that this is the best way, is that you can just implement the OpenTelemetry protocol. So everything here is vendor agnostic. You just point wherever you want to send, to whatever backend you want to send the information that you have collected. And that is all you need to do to make OpenTelemetry then work for your system. So OpenTelemetry has a wire protocol which is called OTLP, and it supports gRPC or HTTP and protobuf or JSON over HTTP. So it's quite flexible. Not every vendor implements every combination. You will need to check what your backend vendor supports. But these are generally the protocols that you can use from OpenTelemetry. And just to give you a very quick overview of the hello world of how this protocol works. So here I have a span. This is JSON and HTTP. Just keep it simple. I didn't want to do gRPC here. This is the minimum what you would need to define a span. So this is, you don't want to do this by hand. This is what a Java agent, for example, would do for you. But this is what happens in the background. So I have here, for example, I have a service that I named test with curl. And then you can see I give it a trace ID and a span ID, and then I call it Spanitron. And then this is like the minimum information that you would need to collect to have like one of these spans within a request. This is not a full request, this is just one span. But this is basically what OpenTelemetry over the network would look like. So what I can then do is I can just curl that to localhost, and I'll show you in a moment what is running on localhost on that port. I just post that message and then it will be forwarded. So what I have running locally here is I have running the OpenTelemetry collector, and for HTTP, that's the endpoint where I was sending this. So the OpenTelemetry collector, the proxy, is taking that information here. These are the receivers, so I can take in both gRPC and HTTP. And then further down here, I have the exporters. Where do I want to forward that? And for example, I have forwarded to OTLP Elastic. Since we speak the OTLP protocol as well, we are forwarding that to one endpoint where we have this running in Elastic. So we have, just to show you what that request looks like. This is test with curl. So this is I'm looking for the request that I have just sent, because I have a lot more requests. So we're filtering down to that. And you can see I've tried this a couple of times today. And this is the request that we have sent in. So you can see this is the manual test, test with curl. And then you can see that this has the information that we gave it. So for example, we know when it was ingested, but for example, a timestamp, since I didn't provide the timestamp when this was created, is epoch, so 1970. So you can have a lot of more additional data in a span to add to that. But this is really the minimum version, what you can do with just the OTLP protocol, or the minimum JSON that you could send. And then the various vendor backends, you could do the same thing with, for example, Honeycomb. You could just send them the data and it would be collected there in a similar way. So that's kind of like what the OTLP protocol looks like. Did that make sense so far? Yeah.
I'm quite unclear, like the word span, what does that particularly mean as context?
Yeah, the span is, you can think of it like one method call. It's basically one thing that happens somewhere. So you have the full request, the trace, and then you have spans which are like subunits of what, and one span can have one or more children, for example, as well. So a span is one unit of work. Yes, it's a sub thing, like a method call, for example. Because when you want to instrument that, you want to know, for example, in this piece of code, I spent this much time. That's why you don't want to have just the full request, but you want to have like the little elements broken out. Any other questions? Cool. Then let's move on. You probably don't want to write JSON yourself. So that's why you want to use the agents for OpenTelemetry. So for Java, there is a library, the OpenTelemetry Java library that supports the OpenTelemetry support. And then there's the Java instrumentation, which supports that Java agent concept to auto-instrument your application. And then it's split up into multiple components, but I think this is maybe a bit too much, or it's more for reference. We don't need to dive into that today. So with the Java agent concept, how do I instrument my applications? So we have a checkout service that we're running here. And we're instrumenting that with the OpenTelemetry Java agent, whatever is the current version that you have. You can say, this is my front-end service in version 1.0, and this is production, for example. So these are attributes that are also standardized in OpenTelemetry. And then you can say, this is the endpoint where you send this, and optionally, depending on the system you have, you might need to have like a secret token so that not everybody can send information there, but only the services which know the secret. So this is what the auto-instrumentation can do for you. And then if you're using, for example, something like Spring Boot that is widely supported, it would be able to extract a lot of information out of that for you. If you're using something more obscure or you want to add more custom metadata, you would need to add manual instrumentation. So then you would have a build dependency, and that is also what you have in pretty much any other programming language which doesn't have the Java agent concept, where you would need to manually at least start what you're trying to collect, or you would need to instantiate at least the agent. But for example, if we have something that if we have a framework here that is not supported by OpenTelemetry yet, let's assume, and then you could say, I am actually starting here, this piece of code, I build a custom span. Coming back to your question, this is, for example, this is my unit of work that I want to collect here. So I'm starting my span, and you hopefully give it a better name, and you say this is the start. And then at the end, you need to explicitly end it. And if it errors out, you can set the status to an error. This is how you collect the information about this. So you have with the start and the end, you have the timing information. And if there is an error, you could collect that error as well. So this is how you would manually do that. This is really only necessary if you have like some unit of work that you want to explicitly follow along, or if a library or framework that you're using is not officially supported, then you might need to do some manual instrumentation there as well. Yes, please.
Last slide.
Yeah.
This is completely vendor agnostic?
This is completely vendor agnostic, yeah. Okay. I mean, the only thing that is not vendor agnostic is the endpoint here.
So the collector is always a vendor selling something to collect? Or is there some open source thing that you can use as a collector?
You mean for the endpoint?
Yeah.
So there is the OpenTelemetry collector that is also open source, but then you always need a specific backend. I mean, the backend can be open source, but it's a specific implementation from a vendor. It's like Jaeger or Zipkin or Splunk or Elastic or Honeycomb or whatever else you want. But that's exactly the boundary. So this is all open source. Where the vendor sits is basically here at the endpoint.
Linked with a vendor or with an implementation, we have something like a proxy.
Yes. So
in this proxy, you can choose where you send things, right?
Exactly. So the configuration possibilities, depending on what is supported, either if you have the vendor exporter here, you would need to configure it here everywhere. As it is with if you support the OTLP protocol, like in this example, you need to configure the endpoints either here, and then it will just be forwarded, but this is still vendor agnostic. It will still probably be in the URL where it goes. But you could also say all of these applications forward just to the proxy, and then you only need to configure it once in the proxy. This is, by the way, pretty common if you have like large data set or like large layouts or large infrastructure sets, and you want to proxy that per availability zone or so. It's quite common to use that collector to proxy and collect in one central place, also to keep like what is talking to what a bit simpler. And you only need to configure the exporter here once, or like where it's being forwarded, whereas these all just send here.
Thank you.
Sure. I hope that helped here. So you can also add custom information. So maybe the instrumentation is there, so it knows the timing information, but I want to get the current span, and then I want to add additional metadata. So for example, here I'm adding a customer ID, which is just a random number in this example, but I could also say like this is the country where they're from, and then the shipping method. So you can add all kinds of relevant information to a span to give it more context, or also to let you search for that afterwards. So for example, if you add the customer ID and the customer complains afterwards and says like, your service is broken or your service is slow, you could then, if you have the customer ID, just pull up all the requests of only that customer to see if they were really slow or what problem they were running into. So like that example that I've showed you before, where you added metadata to the logs to make them richer and more useful, the same thing applies to tracing, where you have more metadata to make it more useful and kind of like, yeah, extend the use, not just by having the collected what is in the framework, but adding the logic from your own application. So let's take a look at how we can actually run this. So I have a very simple application running here. And I can, for example, buy 3 TVs. And when I click on the pay button, it will have a fraud detection. And by default, it will have a yellow background while the fraud check is running. And then it will turn either green or red, depending if my transaction succeeded or failed. And you can see it took a little while, but then my transaction was cleared and it succeeded here. So what I have in terms of application running here. So we have this front-end application that is a Java app with Angular, and it uses the Java agent to instrument it. It has this fraud service, and the fraud service is basically the higher the value of your transaction is, the more likely it is to fail, but it's basically a random number, like 1% or so of the transactions will fail. Then I have a checkout service, like for the actual shipping, just to have a second service. It is using caching through Redis, and both front-end and anti-fraud service rely on Postgres for some information. And then I'm also collecting the logs from the OpenTelemetry collector, and I'm getting some information from Redis, Postgres, and the host. All of these point to the OpenTelemetry collector, the proxy, like you have asked before, where to send that. So I'm running this locally, so everything is basically sending to localhost on the default port. And then the only one place where I had to configure like my vendor backend was in the OpenTelemetry collector. And that's also what I've shown you before in the code here. So by default, these are using gRPC, so my applications with the Java agent will send to localhost on this port the information. And then here, this is the single place where you need to configure the exporter, and then you can say where this should be sent. And further down here, you can actually say which services you want to export. So I'm exporting metrics and traces, for example, and then it says receive with OTLP, and then send to OTLP Elastic out the information. So this is the only place where I have the vendor. If you have a different vendor, you would need to know how their exporter works and how to send that. And that's really all you need to configure to make OpenTelemetry work with another vendor. And then let me generate some load. So I have my application already running, and this will generate some requests. Every little dash is a successful transaction. Every X is a failed transaction. So at some point a little X will appear somewhere in here, and that's a failed transaction like this one. But most of the others are good and are working as expected. So what does that look like? So this was the request that I sent manually through JSON. That's why there is this unknown service, but you can ignore that otherwise. And these are the 3 services that I'm running. I'm having frontend, the anti-fraud service, and the checkout service. Now this is all vendor specific, like the visualization and how it collects and shows that information is vendor specific, but the collection is the same for everybody. And then, for example, since I have the last 15 minutes and I just started running this, you can see how much my latency is. Like at first it was a bit higher. Now my this was when I ran it manually a few minutes before, and this is like what my average latency is now. You can also see the throughput in my service, like how many requests it's doing, and the endpoints, which endpoints I'm hitting here. You can also see if we run into any errors. So for example, here the response was not okay. And you can also see which other services this depends on. So it knows, for example, there's a Postgres database and what the latency for that is, Redis, the checkout service, and the anti-fraud service. And here the impact, for example, is like how many requests you're running and how long they take, and that tells you where to kind of like focus your efforts or where to see how things are going. Just to give you an idea of what transactions look like, and you can see here my throughput is running, my failure rate is luckily very low, it's like 1% or so. And you can see these are the endpoints. In this endpoint, it's taking quite long and I'm running it quite frequently. So this is the highest impact of where I should focus my attention. And it also has more errors. So we could look at this one to see what this is up to. Down here, you can see we have 464 requests collected so far. The red ones were errors. The blue ones were good. You see one sample down here, but I only want to look at the slowest one, for example. So I only mark this one, and then you can see these are my 3 services that are in play here. My API orders was called, and then you can see down to the method, that's the span, what we were talking about earlier. So we want to know how long each method took, and then you can see how they are nested together, for example. So the create here is calling out to blue is the anti-fraud service. You can see the anti-fraud service is doing these requests and it's going down to the select. So because it knows that this is JDBC, and you can see we're cheating a bit here to make it sleep and slower, but you can see the actual database requests that we are doing here. So you could figure out like where are you spending your time and why is something slow or fast. And you can see here these are all the transactions and SQL queries that we are running to get to the point where this is being processed, and then at the end we run the checkout. And you can see the entire request here took 1.4 seconds, and you can see where you spent your time. So most of the time was actually spent in that anti-fraud service. And then we might want to look at this, like why did this take more than a second to run? Whereas the rest of my code was very fast, even though there's quite a few database queries, and we might want to look into if that's really a good idea and if we need all of those. But you can very easily pinpoint where something is or where you're spending your time, or you could also easily pinpoint here, and you could explicitly filter only down to the ones with errors. But you could, for example, see here, I only want to have the failed transactions, and I'm just lazy. I could filter for that as well, but here I'm just jumping around between requests. And you can see here, this was one that failed, and you could then see, okay, this entire transaction failed, and then you can see why it failed. And you can also get the metadata for this service. Like the metadata, like I've said before, this is collecting all the information around it, either automatically instrumented or manually, to give you more context to see why this has happened. So you can see on which host this ran, which Java version, what the HTTP request was, whatever other information we have collected here, where the process is running and how it's running, etc. So all of this information is here to help you figure out why something is failing or where you're stuck. As I've said, metrics are also kind of useful and you can export them. Let's quickly look at some metrics that I've built here. So I have the anti-fraud service has some metrics exposed. And for example, here I could say the rejected orders, and I want to have the sum of the rejected orders. So for example, here I don't want the median, but I want the sum. So every time an order is rejected, it can tell me how much is the dollar value of the rejected transactions. And this, of course, I need to manually instrument to say, this was a transaction where it was rejected, and this was the dollar value that was attached to this span. And with that information, you can see how over time the rejected, or how much money basically your fraud service rejected and how much you potentially didn't waste on fraud. So this is just from the instrumentation, and the metrics, of course, are a manual work because these are application specific, unless you want to figure something out like JVM statistics, which could be automated. But anything application specific, of course, would need to be manually instrumented here, like you see in our fraud service. Let's move through the rest of the slides and then do questions or more demo if we have time. So, who's using Spring Boot? Yeah, many. Okay, so for Spring Boot, you have options of how you want to use OpenTelemetry. So with Spring Boot 3, they have been using Micrometer for metrics for a long time. With Spring Boot 3, which the release candidate came out yesterday, they're basically wrapping OpenTelemetry into Micrometer. So what used to be Spring Cloud Sleuth is now called Micrometer Tracing, and that's kind of like wrapping all of the OpenTelemetry work. So while in my application and my examples have used OpenTelemetry directly in the Java implementation. For Spring, you also have the additional option of using Micrometer, which wraps this further into like how Spring has or Spring Boot has been doing things for a long time. And I would call it like a curated API that is well built around correlating and getting metadata out of your service. So for example, they have this concept of an observer. So for example, here we create an observation registry and then an observation handler, and then we have an observation. So basically we add all of this context in a very Spring Boot-like way to that request. So for example, here we would say we're getting the username, and then we have a user type, and let's assume there's only one user type, so it's a low cardinality field, and they have a high cardinality field for some arbitrary number. So in whatever backend you're using, you could map those differently depending on how well those are supported or what you want to do with them. And then you have the actual log message, but you have all of this metadata around it then, and you would also have that in a trace. So it's kind of like a packaged Spring Boot way of instrumenting that, but in the backend it still can do then OpenTelemetry for you. This might be a bit small, but this is how a custom handler could look like. So you could wrap all your code in a custom handler and then have at the beginning of a method you add this log statement, and at the end you add this other log statement. And then you can add some other additional metadata from a user. So this is how you could wrap everything in a handler. So you're not really relying on the OpenTelemetry way of doing things, but you have like the Spring Boot approach how to instrument your applications. So to wrap up, I hope why distributed tracing and OpenTelemetry made sense, and I think it's kind of like the standard where everybody is kind of like moving to. If you have a different implementation that is working, that's fine, but I think in the longer run, most vendors seem to be more or less standardizing on OpenTelemetry, also because it has this appeal of being vendor agnostic and you don't need to mix a lot of vendor stuff into your applications. Traces and metrics are usable today. Logs are a bit early, and there is also a lot more coming. Like I said initially, observability is more than logs, metrics, and traces. So OpenTelemetry is not bound to just logs, metrics, and traces, but it will add new capabilities as they make sense. So for example, profiling there is a draft for what profiling can look like, or continuous profiling. eBPF on the kernel level on Linux, for example, to extract information without instrumenting applications is also in the works. All of these will be coming into OpenTelemetry at some point. So OpenTelemetry is really the wrapper to abstract what types of data you need for observability and bring that in a vendor-agnostic way to various applications. That's kind of like the gist of it. And like I said, the differentiation between the vendors is on the back end. So how you see stuff, how you do alerting, how you find anomalies in the data. All of that is vendor specific. Only the data collection is standardized now, but that is already a big step forward from where we used to be in the past. And then one interesting thing, will the standardization be more for switching out the backend vendor easily, or will it be more around the knowledge baseline, which kind of like my comparison is like, who is using something like Hibernate to abstract away their database? Probably lots. Who has actually replaced their production database in an application? That's a few, but that's still not that many. So maybe OpenTelemetry is a different story, and it will be common that you switch out the vendor backend, but I'm not sure where or how that will happen. So I think that's something that will still play out. How much time you spend to set up one specific vendor backend and how to make that work. And if you are just like, oh, I see a different implementation for the backend that might be more efficient or gives me features that I want, and you just switch that out or not, I think the vote on that is not quite out yet. But with OpenTelemetry, at least you have the option and you don't have vendor-specific code all over your code base. So you only need to replace it in very few places as configuration, and you don't have any other dependencies on that. Last point, don't just look at your systems when they're broken, because otherwise you will not know what is normal. It's pretty much like learning what marriage looks like by just looking at divorces, because that's how many of us are treating their monitoring systems. They only look at when stuff is broken, and nobody knows how it should behave when it's working. So collect the data, but also make use of it all the time. Otherwise, you will be stuck when you run into a problem. And I think we have like 1 minute or so for questions. By the way, I have a lot of swag. If you want to have pens, stickers, or anything else, grab that afterwards, please. Any quick questions? Otherwise, I'm here for the rest of the day and tomorrow to answer as well. Yes, please.
Is it possible to switch on several vendors to listen from proxy?
Yes, you could have multiple exporters, but it's also very expensive. Especially tracing collects a lot of information, both for the network, but also for storing. So while you could, I'm not sure you should.
Yeah, for example, now I'm using Eureka, I don't like it, I want to use
Yes, you could just either switch it over, or I think you could use multiple exporters in parallel. So that's exactly the point of why you might want to use the collector, for example. So you have that in one place where you can switch that out or add multiple ones to make that easier. Anything else? Otherwise, find me afterwards. Happy to answer anything else. Thanks a lot.